Hello and welcome everybody to Howdy Partner, our weekly Twitch series hosted live here on the AWS Twitch channel. Thanks for being here. So every week we use these 1.5 to 2 hours to showcase our amazing partners in the AWS Partner Network and the innovative solutions that they build on AWS. Now, who am I? My name is Jerry Tejada, and with me today is my co-host Simon. We are partner solutions architects at AWS, and a big part of our job is technical validations, architecture discussions. We work very closely with the amazing community of partners and customers that we have here at AWS. So I'm tuning in from New York. Simon, where are you tuning in from today?
I'm in Bellingham, which is a couple hours north of Seattle, Washington.
All right, love it. I used to live in Seattle myself. I know I really love it up there. Whole different world, that the Pacific Northwest. Please, to everyone in the chat, drop in where you're tuning in from today. Let's hear where our audience is from. I will let those roll in. Well, you know who we are, and now you know where we are. So now let's talk about today's guest, who we are very excited to have here on the show, and that is Vertex, ladies and gentlemen. So on today's episode, our partners at Vertex will show us how to use their extended reality services and solutions. Super excited because I myself am part of the spatial computing technical field community. So spatial partners are near and dear to my heart. And that's what partnership is about. You know, us at AWS, our partners at Vertex, helping you all, the end customer. So that's enough of me. Let's bring in our friends at Vertex. Chris, Jim, welcome. Thanks for being here.
Thanks for having us.
Thanks, Gary.
Yeah, of course. Happy to have you. So if you could just quickly introduce yourselves to the audience, we'd love to know who you are. And of course, we'd love to know what Vertex is all about.
Yeah, thanks. I'll start, Chris, if that's all right. My name is Jim Zwica. I'm a mechanical engineer out of Iowa State University in the middle of the United States. The interesting part of Iowa State is that we've been on the forefront of massive model visualization for a very long time. And I got started at a company called Engineering Animation Incorporated while I was an undergrad. This was back in the 90s, so I'm kind of dating myself there. But the interesting part is that was one of the key transitions from 2D to 3D models. And so CAD started to start doing 3D models as a default. And then quickly they started to ask, we need to bring all of these CAD models together into a single environment. And so we were lucky at Iowa State that we had access to very expensive visualization machines in the form of Silicon Graphics computers. And collectively, with the help of professors and the company, we were able to build some of the very first frameworks of massive model visualization. And so people may know the JT file. They may know the Viz Mockup viewer, the Teams, the embedded viewer in, say, Team Center. All that was originated here in Ames, Iowa, and we were ultimately bought through a series of acquisitions by Siemens. And I spent a big part of my career doing, implementing visualization around the world for Siemens. And after 20, 30 years of doing that, we realized that a lot of that technology had been very, very stagnant and had changed a lot. It became very hardware dependent. And so we decided to start Vertex to address a few of the pain points that I'll get into a minute after Chris introduces himself. We saw a really nice opportunity here to start this company and really make a big impact in the visualization space. And so we were excited to show you. Chris?
Yeah, thanks, Jim. So I did mechanical engineering at the University of Iowa, so the other side of the state, but Jim and I will let that be for now. So, early in my career, it was vehicle design and manufacturing, and then went into motorsports racing specifically for quite a few years. And a lot of what we're going to show today really highlights the struggles we had years ago. I don't need to date myself. The gray in my beard does that for me. But these massive model visualizations that we try to do with suppliers and OEMs and other manufacturers, even departments within our organizations, the struggles we had trying to go through that 2D to 3D, and then simply the compute power required to manage the 3D visualization. So I've been with Vertex now about a month, so this is my newbie card. So if there are very difficult questions, I'll defer to Jim. But Vertex is a company I've been following for quite a few years, just because of how disruptive and unique their technology is. It solves so many problems that we struggled with really for decades in the industry, and what we're able to do and what we're able to help our customers do is really remarkable on the AWS platform. So really looking forward to walking through a bit of what we can do and how we do it today. So Jim, I'll kick it back over to you.
Yeah, I think I'll start sharing. I probably could have done that while you were talking, but
no worries. Thank you both for that. Chris, you mentioned motorsport. You got me all excited there as a big F1 fan. I don't know if there's any F1 fans in the audience, but
I'm sure there's a fair few. I was in Corvette, Cadillac, and NASCAR racing, so over the course of a decade. So kind of mini race series, but not F1.
Very cool. Very, very cool.
Very fun. Yeah. What was your role in your involvement?
Really, I guess the best way to describe it is kind of analysis engineer. So we did a lot of predictive modeling. So it all was predicated on the CAD, the geometry, and then kind of what would a vehicle do based upon how we change that geometry. So we struggled for many, many times trying to visualize and understand small changes design engineering would do, what the realities of that were in the field, and then ultimately how the driver experienced that as we assembled the vehicle and put it on track.
That's cool.
And then speaking of automotive too, that's at least at AWS, we're seeing a lot of movement in the automotive space with regards to spatial computing. So definitely a lot of action there from our side.
Yeah, I mean, they're some of the earliest adopters traditionally. I did spend a big part of my career in the Detroit area helping the OEMs there implement their very first 3D visualization options, and it's matured quite well. And you even hear back now that we've put that in place, and you hear 20 years later that they haven't had any buildability issues since implementing 3D visualization with our software. So that was really cool. Our software meaning back in the day when I was at Siemens. So anyways, yeah, so if we're good here, then I have a slide here up that says Vertex, and one of our customers said this to us and we liked it, and so we went ahead and put in Netflix for CAD.
I like it.
And it's kind of one of those elevator sort of things where, like, if you're going to tell someone quickly what you do, and assuming they're an engineer, if you think of what Netflix did back in the day, is they used to send you, a DVD, or I don't think they ever did VHS tapes, but consider that like a file today in the engineering space. So today, generally speaking, if you want to do something transactional or viewing something in a CAD or an engineering sort of space or workflow, or something gets sent to your device, and then the assumption is that what that thing is, you can open it, you can interact with it, and you can do the work. But they're literally relying on you to have that hardware and that software in place to do that. And as Netflix proceeded, all of a sudden now, like, if not one person knows what format it comes in, they don't care what device they watch it on. They don't worry about, do I have enough space for this? All it really is an API call to get a result, and that result is what they want to see. And that's literally what we did with respect to the engineering, the file-based sort of world that is, engineering, design, collaboration, extended enterprise, consumption, aftermarket, that sort of thing. So, like, if you think, to get into a little more detail about that, as I spent my whole career, and a lot of the team have spent their whole career working on problem solving, there was just a few areas that sort of percolated to the top to say, what's blocking us from being able to look at the biggest models? What's blocking people who are downstream of engineering, like even in manufacturing, to be able to consume what they want to consume, how they want to consume it, without the heavy overhead of asking engineering to prepare something special, or to taking geometry, or pulling it out of the main workflow, orphaning it off, and then using it for their special purpose. And we spent a lot of time figuring out what can we do to really eliminate a lot of that problem. And I mean, there's things that we want to be able to do too. Is oftentimes when you want to look at a lot of geometry, you have to reduce it down, simplify it, put it in a different format. And, you really want to eliminate the scalability of the, that blocks a lot of these downstream users. So, we wanted to be able to essentially have infinite BOM lines. Infinite, I should be careful about that. But, if you have millions of BOM lines, we want to be able to handle that. Billions of triangles, we want to be able to handle that. Hundreds of thousands of concurrent users, we want to be able to handle that. And today's answer on all of those fronts is throw hardware at the problem. Spool up a big GPU, whether it's on a client device or whether it's up in the cloud, CPUs, etc. And ultimately that runs into a problem because of cost or scalability, or, just the experience dilutes. And so we wanted to see how can we get rid of all that. We wanted to make it economical. We don't actually use GPUs in the cloud or on the device, which for a minute, we'll kind of get back to that a lot harder here soon. But the point being is that, even if you say, okay, we'll just kick the hardware problem up to the cloud, rent the GPU for a little while, it's still a lot of the legacy issues are there. I don't think you're using the cloud or AWS in the truest sense that it was written. And so, that's the key, is that we want to have a way to create experiences that are very rich, very impactful, but also very economical. Let's see here, looking at some of these things. So, the data transformation part of this, which we'll get into a little bit as well, is what's really important to us is we want to stay in the main workflow of an engineering process. Meaning, if you're getting your information from your PLM system, you don't want to break that. You want to be able to make sure that you always have the latest design intent, latest released information, and then let Vertex and the downstream handle, this persona wants to see this geometry in this way. So, you'll see that how we've kept that very nimble. I think I alluded to earlier that oftentimes, if you have numerous personas, that want to be able to view things, they create special geometry just for those use cases. At Vertex, we've built this in a way that everyone's using the same geometry. That geometry is still aligned to your native data sources, and everyone can consume it in their context, how they're supposed to see it. And but you don't have to ever orphan off or have special, geometry for them. So again, we'll get into that in more detail. And then the other key part of this, which is a big challenge for everyone, is the security. The way we do things, we don't cache geometry on your device. And so effectively what we do is we call it contextually streamed pixels, meaning that we don't take geometry, we don't put on a device. All the interactions that you do generate images on the fly. So those contextual pixels are sent for you. So you feel like you're working with 3D geometry, but you're not. So I'll just move over.
Jim, real quick, before you jump forward,
Yeah.
We love innovation at AWS. What can you share about the patents? Where do your patents become involved with your process?
Yeah, so we had to totally rethink how rendering is done. And I don't know how about this audience, but we'll get into it a little bit. Generally speaking, the rendering is pushed down to your client device. So whether you're using WebGL or your GPU or that sort of thing, it becomes a dependency on the hardware to handle that. What we've done is we've created a way to render at the subpart level. And so what we do is we massively fan out each part that's been subdivided, render those individually, and then we composite all of that into a single image. So all of the parts, I'll show you more in a minute when we get in there. And then that image is what gets streamed, but the generation of the image is kicked off by an API call or a gesture on the client side. So, and again, I'll get into it more in a minute, but what kind of put us in a spot where we said, this is the way to do this. This is the correct way to do this. Is let's not be forced to have files generated in order to do this. Let's distill this down to an API call so that no matter who you are, you're going to see things how you're supposed to see them and go from there. But yeah, it's
that's pretty cool. It's interested to see how that fits into the demo.
Yeah. I mean, it took us years to do this, and we patented it, and we were very proud of that. And we weren't here to kind of make just an incremental increase in the performance and massive auto visualization and the unleashing of this geometry, and getting a lot more value out of what's traditionally been trapped in the engineering space. And so that's the idea. So there you go. Up the upper left, you see is, kind of reinforcing what we just said is, context aware pixels. We don't cache anything on your end device. The key there is your IP is under your control, so we can get into that more in a little bit. A lot of people say this, but we are truly device agnostic. So you're going to get the same experience on your engineering laptop as you would on your phone. And we were at a conference last couple of weeks ago, and a lot of the demos we did on a Raspberry Pi, So really all you need for us to be very performant is a connection to the internet and a browser, essentially, and you're going to be able to get very, very good experiences with us. Zero install, I guess, is kind of self-explanatory. We do ingest over 70 different file formats. Once it's in Vertex, they are no longer in that format. We don't keep whether it's CATIA or NX or Creo or any of the neutral file formats. We do import them, but once they're in there, they're in our special format that allows us to render the images very, very quickly. We do keep the bill of materials. We do keep the NURB data, et cetera, for engineering sort of analysis purposes, which we'll get into in a little bit too. And then we talk about massive models. We can bring in billions and billions of polygons, millions of bomb lines, and that's the idea there is that you're not limited. It shouldn't be a question of, hey, we want this off-highway piece of heavy equipment to be put in front of the customer. They should be able to see exactly what they bought in the configuration that they bought. And it shouldn't be, oh, shoot, we'd love to do that, but how do we create that file, or how do we do that, or how do we deliver it to their device, that sort of thing. And so, you'll see what we're going after and why we do that. And the quick time to value thing is, we have an SDK. We have a tool called Connect that we built on top of our SDK. And again, we'll get into all of that here soon.
Jim, if I could jump in real quickly on the last slide there. In the 70 file formats, it said CAD. So I think we're going to be talking a lot about CAD today. So if you could just, for the audience, maybe a quick rundown on what CAD is, what industries are using it, and maybe why it's important.
Yeah, CAD's an acronym, computer aided design. There's a bunch of different flavors for that, but in essence, what that means is that you're making through your software a 3D representation of your geometry. For decades, they used to make 2D drawings, and so the 2D drawing would have essentially the different sort of views, like a front, the side, and maybe an ISO view, with the information required to manufacture that or assemble that. As I mentioned a little bit earlier, in the early 90s, most big engineering companies, automotive, aero, et cetera, were formally moving into the 3D space. And so the CAD model itself is what they were using to build out, like say, I'm making a piece of suspension, maybe someone else is making a piece of the muffler or something in the interior. Well, you would have hundreds of engineers who are creating CAD models. And the challenge was, well, how do we take the collective work that everyone is doing, how do we bring it into one spot so that we can all collaborate on it? Is everything going as we expect it to go? Because oftentimes, and again, back in the day, they would make these prototypes and they would not discover issues with the collective work that everyone had done until they made a physical prototype. But by then it's months too late, and you're getting incremental fixes in. And so the idea was, with all of these CAD models, CAD assemblies, we want the ability to see, let's say, yesterday's work that all the engineering collectively did. I want to be able to see it today, so I can make sure that no one put something in my spot or there's no interference or that sort of thing. And so that was really the push back then. And those are the tools that we were building in that day, and they've done really well. But as I say, as things get more complex, as the customer base wants, more unique, like a special configuration for me and only me. You're not stamping out widgets anymore. You're heading towards complexity where everyone wants their own special tool, and so. To support that, to be able to view it, to be able to maintain that, you needed a new way to be able to visualize that. And that's, again, one of the key drivers at Vertex that we use to do that.
Awesome.
Is that fair?
No, that's great. That kind of led right into why Vertex and all that. So awesome.
Yeah. So just a little bit of infograph here that I'll kind of quickly go through, but really the key thing is we've hit the input of all the CAD models being stored and available in the Vertex part library. The push here is that we want to be able to supply great user experiences and user interfaces to not just the engineering team, but other non-traditional, I guess you could say, but now becoming not just a nice to have, but a mandate. You want your you want for your request for quotes, like your supplier base, to be able to interactively work together. You want your end customer to be able to quickly order parts. You want, and then accurately making sure they're picking the right thing. During assembly in the manufacturing plant, you want people to have the phrase is the digital twin. You want to have the physical have a digital twin next to it so that they know that they're putting their, this thing together appropriately. Again, bringing up the uniqueness. They call them snowflakes, so like some of our customers will build a single configuration of a machine every few years, but their operators have to understand how to put together, I just put this together. Now this thing I'm putting together is completely different than what I did. And you want 3D to come in and play a very important part of that. And so, and then as well as quality, right? So you want to be able to pick quality, like say something's leaking, on the assembly process, you want the digital twin to be able to highlight if there's a problem with that. And then that goes into their systems. And so, anyways, it's the whole idea here is that we want to be able to deliver great experiences for not just the engineering group, but for the entire extended enterprise and beyond. And I think that's it. And as far as this is concerned, we can hop into a demo.
Awesome. Let's rock and roll.
All right. So we'll get into this a little bit more detail. I'll come back to this, but what we want to do is provide. So this is the Connect tool that we've built out. The idea here is that it looks very familiar with people. They look file based. It's structured in a way that you can have certain groups and different workspaces, that sort of thing. But that's where the similarities end to a file based system. So once I click on a part here, you'll see that the geometry loads very, very quickly. And I'm going to do a few things here. I'm going to take the bill of material. I'll just expand it all the way out. I'm going to select this body and I'm going to say, let's ghost this up. So now you can see with a little more complexity here coming in. Now, again, it's to kind of reinforce what's going on is that none of this has been cached to the end device. We're not using WebGL. We're not using GPUs in the cloud. We're not using anything like that. What we're doing here is we're creating everything I'm doing is a gesture that goes back to that goes back to the Vertex part library and says, I need to see this geometry from this angle. I'm going to select the cam cover here. You're going to say, I need to see the cam cover highlighted. And so then I'll just zoom in a little bit more, but literally everything here is a gesture that, goes back to Vertex and says, this is what, based on this selection, I need to see this. We are getting a little bit of lag, just so you know. So I'm going to go ahead and hide this part, but this gives you an idea of the level of fidelity that we're able to get. We don't reduce, decimate, simplify the geometry at all. So you can see, as I start taking some parts off, everything is literally as you would see it on the engineering workbench of your CAD software. So the idea is that you give everyone the geometry they need to see and how they need to see it. So, I mean, this is kind of like the key, difference between putting file-based on your device and doing gestures to get results. So I'll stop for a second to see if you guys have any questions based on that before we continue.
Yeah, so if you could just, so what's the advantage of not caching it on the end device?
Yeah, so just remember, if when we talk about no files, that is the exact opposite for what everyone else is doing today. So what actually has to happen is, they will take that simplified geometry or that geometry, and it's got to go over the internet. So it could be hundreds of megabytes in size. So think about taking all that geometry in file form, dropping it on that device, and then waiting for that device to open it, put it into RAM, and then use whatever software or hardware is there to start generating an image. That's the time, killer. Especially as you get into the, the serviceability or the maintenance groups, or even engineers, that's this time they're not willing to spend. And you have to do a bunch of design. You have to do a bunch of special preparatory work to generate models that would be ready for that. We've eliminated all that. So what we've done is, this is nothing more than an API call. So when we're rotating, spinning, when I select the air filter here, all of that is a quick API call to say, I need to see an image that makes it look like I just selected that air filter, but all that's really happened is we got an image back that results. So that's really the key idea here.
No, yeah, that's great. So yeah, I see a lot of use cases for simplification, needing to simplify these polygons down to make it more performant. So you're saying you don't need to do any of that simplification?
Not at all. In fact, we maintain alignment to your PLM sources. A lot of anxiety you get from big OEMs is that the IT group will think that you're creating a whole new master source of record here. And that is anything but, we're the complete opposite of that. We align to your native sources, and, we maintain in our part library the connection back to your PLM systems, your PDM systems, your MES systems, whatever. And then, the great part about that is that you never leave the workflow. So if something new comes in, then that new geometry will show up wherever it's supposed to show up, whether it's in some customer portal where they're able to buy, new parts or new assemblies, or, in discussions with your suppliers, that sort of thing. So it's really, really great.
Very cool.
Yeah.
I also mentioned too, right, by streaming the pixels, right, we're giving this very performant experience, this great end user experience, but there's also intellectual property protections here, right? We're not streaming or providing part files, we're providing pixels. Mm-hmm. So as you can maintain your own proprietary information, but yet collaborate with others that you need to collaborate with.
Yeah, thanks for that, Chris. That's super important, because I know a lot of customers are, rightfully so, extremely protective over IP, and that's a big concern in a lot of these workloads. So it's really important.
Or switch the size a little bit here just for a second. All right, so I'd like to kind of get into certain sort of personas and use cases here. So we've discussed engineering and engineering collaboration, and and of course, people please jump in and ask questions as they come up. But with respect to that, what we did here is actually we merged a bunch of geometry together. So like if you notice, if I take like this engine and open that engine up, it's it could have been delivered by a supplier, and they would have in the workspace been given access to the workspace by their OEM, and the OEM would have said okay, hey, can you please give us your your V6 that we want to consider as a an option for the Corvette here. And so so that would be there. I'm going to hop back out, and then you'll see there's a few things with the transmission, rear suspension, tubular frame. If I open that up, but the idea is you want your extended all of your supplier base to be able to work together with their OEM without actually having to send 3D geometry to each other or send like sensitive IP information to each other. And so Vertex actually allows you to bring things together in context without actually giving each other your sensitive IP. So I could take, for example, this engine and this tubular frame that we just opened both of those. I could say merge those together. Oh, I must have not selected a second. And let's merge that together. And then you see those together, and I can just say AWS day and create that model. And that'll go ahead and merge those together. If you think about how this is done today, they would take these two models, they would open a CAD system, they would create a dummy node in the CAD, and then that would then have to be exported out and then delivered to someone in order for them just to see those two things in context. So there it is. I'll just go ahead and open that up. And you'll see, just like that, those two pieces of geometry are together. So you can immediately then, I haven't given you my stuff, you haven't given me your stuff, but I can bring them together and we can see this is, if we were to build this in the real world, this is how this would look. And then you can do cross-sectioning, that sort of thing here. If I can zoom out here a little bit, be able to go in there, take a look. But you've literally not given each other your work, but you're able to do all of the analysis, all of the work that you would have done traditionally without any of that effort to, with the files that you would have to do. I mean, in literally just the seconds here, we're able to bring geometry together and you can work with it as if it has been put together. So it's a very, very powerful way to do collaboration, especially when you're with your suppliers and not to mention, companies that work, globally, where they'll have some people working in Europe, and then you come up in the morning and then have to look at what they did. You can immediately get started without having to pull their files, merge them together, that sort of thing.
Yeah, like if you talk a little bit about like how did we used to do, like how long would this have taken us, back in those days that we mentioned earlier at the kickoff, Jim?
Yeah, I mean, it's just, well, and it was insane. Like I mean, the fact that you're able to look at these, just the idea of bringing it all together in the first place. And the best we could do back in the day would be maybe 2 or 3 days where you would collect all the engineering information together, which wasn't bad, which was very good because it was an improvement over months from before. But this is literally, seconds that you're able to bring geometry in and work together.
So can we talk a little bit about how that would work? So say I'm one company and I want to merge my file with my supplier.
Mm-hmm.
They don't send me the file.
Mm-hmm.
I hop on the portal here. What do they send me in order for me to be able to put those two together?
Yeah, thanks for that question. So what they would do, they could formally connect. We'll do it through the GUI here. Just because it's very visual. But what you could do is just have their two PLM systems, product lifecycle management tools, could be connected to the Vertex part library. But in this case, like, all of these supported models I talked about, the different formats we have, this is a little bit of a list of those. But what they would do is they would just say, so I would create a workspace. I would invite my suppliers and my OEM together. And then once they're in that workspace, they would be able to say, okay, I was told to import that engine, for example. So they could just sit there and they could select CAD file from their file system or an assembly, and then literally import that in. Again, once it's in Vertex, no one has access to that 3D geometry. They're able to again work with it together, but they haven't given them the actual physical CAD model itself. It's just available to consume. So this here is a list of, if I go over here and say I want to create a version of this, what you'll see is these are all the models that were brought in, and they can be brought in from numerous suppliers. And then if there's new stuff to come in, they can come in here and then select, the different things that they want to select. So this would be a collection of numerous suppliers bringing all of their work together. And then everyone can collaborate on that together. So for example, let's go ahead and do some collaboration so that you can see how that would work. I'll turn that off. I'll zoom in. And one of the things we did I did discover some things here earlier. So I might notice that there's an issue with the engine where it's placed and the suspension. So like the exhaust manifold can't make it out. And so that maybe your engine supplier and then the OEM say, hey, you know what, this engine isn't in the right spot. Can we move that? Well, how would you collaborate? How would you talk to your supplier about that? Well, we have a concept called stories, and we have these snapshots here that allow you, and I'll just kind of hop through a couple of these so you can see that you're able to save different states. And this allows you to kind of hone in on areas or create focused areas that allow you to have conversation. So let's go back to where we were here. And so we have, watch it slide back a little bit. Okay, so we want to go in here and have a discussion about these two areas here, and that we have a problem. So I'm going to go ahead and create a snapshot for that. And what we'll do is we'll create a story that will allow me to talk to my supplier about the engine. So we'll go up here. So there's that snapshot. I'll just call it issue A. I'll select that. I'll come down here and I'll select some other snapshots so they're able to see.
These snapshots are just 2D images.
I'm sorry?
These snapshots are just 2D images. So
no, they're always, well, it's a 2D snapshot, but they're all fully interactive. So it's more of a state. So there it is. So you can see how you can still work with it that way. And then I put in, so 3 snapshots. So we can call this issue A, for example. And I'm going to come in here, and then if you notice the comment tree over here, I'm going to go ahead and mark this up. And then Chris is my engine supplier, so I'm going to yell at him. And he's from NASCAR, so, they would have messed some things up maybe. But you can go ahead and do some markups. You can drop 3D pins. You can put, 3D text here. I might want to put it, something like this here. A second. That sort of thing. And I'm going to save that out. And what it's going to do is collect all that together. It's going to put the snapshot right here. And then I'm going to be able to go to say, at Chris, is the engine in the right spot? And then submit that. And then it's going to say, well, you haven't invited Chris to this story. Would you like to share it with him? And so I'm going to go ahead and do that. So now Chris will get a notification. He'll get access to this story. I should mention that all of this is under the customer's control. So they can, make sure that, the suppliers that you're talking to are whitelisted and they're allowed to be, to be added to the story. You have full control over everything. And in fact, one of the interesting things with Vertex is that when you're sending images only, you actually have full fidelity over every feature. And what does that mean? Well, that means that I might not want you to say measure or cross section on this one because the full product is here. But, and I didn't reduce one down here, but so let's say I reduced it down to just this area, if you don't mind. And what we can do then is I'm going to be able to enable you to measure a cross section here. So if you notice, there's no dialog boxes for those. Let her hop back out. Oops. And I'm going to say enable measurement, enable cross sectioning. And so now I'm going to go in here. And if you notice, those are now both there. So now I will let you do measuring, that sort of thing in here. And so you get the fidelity of, geometry that's been, vastly reduced in this area, and then allowing them to do certain things, but then also giving them the context of the broader context where they're no longer allowed to do that.
Yeah, and that's an important differentiation here, right? If I'm the engine manufacturer, and I'll blame Jim for the interference on the mounts, but what's inside that engine is very proprietary and highly sensitive, right? So by giving me the ability to allow Jim not to look inside, because the only parts we care about are where they interface, right? Where they mate, where they match up. What's inside is really irrelevant to what Jim's trying to do. And in Vertex, through the permissions and context, we can control that and give you access again to the actual CAD that's tied back to the source systems, kind of in the context, in the time you need it, with the permissions that you should be granted for it.
Yeah, let's lean in on that a little bit. So like, let's say, Chris's engineers, of course, can, pick whatever they want here, get inside, look at the springs, look at everything. But for a packaging purpose, that's by no means something that they need to be doing. So I could actually select the entire engine here. So you'll see I'll do a series of selection that'll just crawl up to the engine. So that's the whole engine here. And I can say, okay, so Chris would want to deliver to me, he wants to eliminate my ability to get inside. So what I'm going to do is I'm going to pack these lines up. And so if you notice now, the engine is now all on or all off. So if I select the cam cover again, the entire thing is now just one bomb line versus the hundreds of bomb lines that it was. So it's a way that you can control your IP and protect it while still being a team player and allowing, the customer, in this case, your engine OEM or your automotive company, to use this engine and put it in and make sure it'll fit, but it doesn't let them get inside. And then while I'm at it here, I'll just go ahead and say, I'm going to, say, hey, we need to maybe move that out of the way. And so I'm just going to slide this around and, then maybe take another snapshot to say, hey, it looks like, you put it about, I don't know why that's in feet, but about 3/4 of a foot, in the wrong spot. So I'm going to go ahead and slide that over, create another snapshot. And then that could be part of the story here as we go forward, to say, I'm going to go ahead and add that to the story. I'm going to hop back out, go to our story, and now I'll add that snapshot and put it right here. And then this will be my suggestion back to Chris to say, hey, it looks like if we move it up to here, then this will be good. So it allows you to, to do all of that activity. So I'll go back to here. And so there's that. And then I'm going to slide over. It's going to move over, and then you'll see it slide forward like that. So it allows you to have these discussions and quickly go through, engineering, design iterations, that sort of thing, to have the right conversation, with the right people without having to, send physical models back and forth to do so.
Or do this via Slack or email, or, we're we're collaborating in the platform here, and that's what's important, right? So we're streamlining this process, making it much more efficient, eliminating the noise around this process.
Yeah, definitely. And does this collaboration, does it usually happen asynchronously like that? Like, you review, you make your comments, and then you send it back. Does this ever happen in a live session? Is that something that ever takes place?
It does. And we have in our beta environment like a live meeting where you can actually, everyone can follow the leader sort of a thing. But quite frankly, most of our customers tend to do this asynchronously versus bringing everyone in for like a formal design review. So that this is asked for vastly more than the other. The other is certainly very feasible to do, and it's in our plans. But right now, again, we want to make sure that the asynchronous experience is as good as possible for everybody.
Yeah, that makes sense to me too, especially, suppliers are in different locations and all that with time changes. So you could just kind of review it on your own time, make comments on your own time, and then send it back over. So that makes sense.
Yeah. Let's see here. Taking a look at my list.
Based on your explanation of the permissions, I'm assuming you control permissions at the part level, at the group level, at the full assembly level. So say you're the OEM and you need access to measure the bolt pattern to mount this motor. Mm-hmm. Is there an easy way for them to communicate that to the supplier, or how is it just they need to Slack them, send them a message, or is there a way to mark it in case I need measurement access to this part?
Yeah. I mean, what they would be able to do is like, so let's go back to this example here. Like they may say, what, can I get access to the internals here, please, for whatever reason? Yeah. Then it would be up to, like you said, is the control is done in this case probably by the OEM, where they're giving the supplier right to view for that moment. Mm-hmm. And they would just tweak the access so that they would have the ability to get inside of the engine, that sort of thing. And that can be down to the individual company, individual person, individual part or assembly, so that's all there. And then maybe an interesting thing here also is that oftentimes you may want to obscure the areas around. So you may not want people to be able to see certain things. By that, I mean, you want them to not design in that area, but you may also want them, but you don't want them to see what you're working on. And just to give you a little idea of what that might, again, this is kind of giving you a little peek into the future here a bit, but maybe we may want to, so we have different rendering modes here, or you may want to take off the shading, and then I can turn off this too. So you could say, I'm going to let you see everything here, but you're going to then design over in this space, but you can't actually extract any sort of information here that would potentially allow you to reverse engineer it, for example, if that makes sense.
Just to jump in here to the audience, please do ask questions. We are here to answer them, whether from our side or on the Vertex side. So don't be shy. Definitely, if you see anything you don't understand or want some more details on, definitely go ahead and ask some questions. We're happy to answer.
Yeah, for sure. And so what I'm going to do here now, though, is kind of start to pivot over to Chris and let him show some things. But the key thing to remember is everything we do is essentially an API call. So all of these snapshots that I created are unique identifiers. So if you see up here, so what that means is that you could actually call them, with your SDK and embed them into any sort of tool, any sort of UI UX that you have. Again, the idea is that you're always connected to your native source, through the Vertex part library. So your extended enterprise can embed these in, and the way they do it is with our SDK and then all of the unique identifiers. And so one of the key areas that has gotten a lot of traction for us is the e-commerce side. I've brought up, if you have an off-highway heavy equipment company who makes snowflakes for their customer, you don't want them to have to type in a dialog box, bracket, or alternator or whatever. And then they have to, well, what kind of bracket? Well, I have this machine. Like, you're actually relying on the customer to type in all the necessary information in order to get to what they hope is the right part. And instead, what they want to do is they say, you know what we should do is say, welcome back, customer. Here are the parts here's the machines that you own. Select the machine. The entire machine shows up. They select the part they want. They add it to cart and so forth. So to highlight that or demo that, I'm going to throw it over to Chris, and I'll stop sharing here. So Chris can do that.
Before we do throw it over, this is more of a trivia question, a bit on a personal personal side, but
Sure.
what year was that Corvette from? Because that is a spunky car.
I think it's the late 50s, if I remember right. If I asked my son, he would tell me, and he would yell at me in 2 seconds, but it's either early 60s or late 50s. And
maybe somebody in the chat is more Corvette familiar and can
yeah, maybe someone can answer a little trivia question here. Yeah. I almost like it better than the way the Corvettes look now. Yeah, that's a great car.
All right. So I will expand a bit upon what Rob started. So everything in terms of kind of the value that both suppliers, OEMs, et cetera, and even end users get from the Vertex platform persists. So what I'm showing here is an experience built on the Vertex platform utilizing our web SDK. So this is kind of an e-commerce site or an aftermarket or parts catalog. So if we think about that car, that engine, or in this case a transmission, right? I've built this, I've sold it, and now things will inevitably break in the field, or customers may want to repair and do things with it. So how do they easily find those, right? Their serialized assembly, their actual one they have, and that experience is very difficult. So what we've done here is create a way for that to be available for customers to come in and easily discern the parts they need, have confidence that they're the correct parts, and then order those. So let's say, for instance, I know I need to replace a ring gear in this transmission. So I've opened up my assembly that I have. I can see every single part in this assembly, the part, all the metadata associated with it, the ID, the number, the quantity, how many of these do I need to order? So I can click on that and it will highlight within, it'll zoom in a little bit. I have the ability to really kind of isolate that selection, right? Ghost the parts around it to see, yep, is that really the one I need? Is that the correct part? But if we think about looking at this at an assembly level in terms of the full packaging, it's maybe not as elegant, maybe not as easy to discern. So I can hop back over to Connect, which is what Jim was in earlier, and I can create different stories, different snapshots that we want to make available as part of this e-commerce site. So rather than the assemble as is assembled, I could have more of an exploded view and have that available. A much easier way for an end user to look at this and say, yes, that is indeed the part I need. Because it's connected to the system, we always have the correct parts, the right vision of the parts, quantity, any sort of metadata associated with it, right? We have not created an orphaned assembly here or orphaned visualization. And that's very important to get somebody to come back and to have engineering create this. This might be a day's worth of work to simply just create this, track down all the correct parts, give us the view we need, rather than using the Vertex platform to explode this, transform these parts, and create snapshots and publish them to the e-commerce site very easily. Before we publish this one and interact with it, I'll call out a few things here. There are other versions that we have created that we could publish as well. For instance, you see part of about 2/3 of the assembly here are ghosted out. That may be because they're not, serviceable parts. We don't want people to order them. It's too difficult, or we just don't want to make them available in the field. But for today's example, we're going to look at the full assembly, all the parts. And if I want to make that available in an e-commerce site, I simply publish that. It will refresh and hop back over to the viewer. And now we're going to see it in a much more intuitive, user-friendly way. For instance, now I know I'm looking for that gear. I can select that part. It will zoom in on it. I can click to zoom back out. What does that interact with? Maybe there's something else I want to get. So I can search, what other gears is that maybe made up with? So by using the search feature, it starts to pare down and will ghost the parts that aren't representative as part of that search query we've run there. I can turn that back off. I could search by part, part ID, part number, part name. I also can see here that, hey, there's actually, there's the housing that this interacts with. I may need that, I may not. So I'll zoom back out, but let's just say I want to go in here and select the ring gear, the pinion, and the associated bearing and snap ring. Now I have them all together. I can simply add those to my cart, select, and purchase those parts with confidence that they're the correct parts. And this is important at the OEM. From an OEM side, aftermarket parts is a very important revenue stream, a very large revenue stream. And when you don't create a great user experience, consumers will go elsewhere. They'll go to other channels, other avenues to buy parts because it's an easier experience. It's also, I might make, let's say for instance, I know I needed a bearing. Well, I may not be sure which bearing I need. I may order all 7 of these bearings and then return the 6 I don't need. That's heavy inventory. There's a cost component to this well on the OEM side. So this is a way to, one, give an end user who's purchased a product a very elegant user experience, but 2, be an important source of revenue stream for an OEM, as well as kind of minimizing those costs. We have many of the same views. This may not be the way that we're kind of used to looking at this. We have the same sort of things Jim showed, the ability to toggle through different views, right? We can flatten those colors. For those of us who were used to working with the old black and white 2D drawings, we can flatten it a bit to more that, or even just create simply a flatter color view of this. But I tend to like this more modern view here. It's easy, it's intuitive to work with. It's connected to PLM. I'll pause there. I've been speaking pretty fast. Want to make sure if Jim wants to add anything, or if you guys have any questions about this experience built on top of the platform.
Well, I think this adds huge value. In a previous role, I was involved with industrial equipment development, and I can say that I would choose vendors that had 3D models available, but nobody had this. If somebody had this, that would have been like a game changer as far as where am I getting my parts? How am I going to design my end product? So it seems really cool to me.
Yeah, no, I had a very simple one recently. I needed a new part for a grill, and I couldn't find the exploded diagram. I couldn't find the part, so I just went to the hardware store and bought something and forced it to work. Because that was the easiest way to do it. As opposed to getting the one that would have probably saved me much blood, sweat, and tears.
One thing to bring up here is, generally speaking, companies keep different sources of data, different metadata, different, like customer-facing information is over in this database, engineering information is over in this database. And if you wanted to bring that together, you generally had to move it into one of the 2 spots. And with the way we built out Vertex is we wanted to be able essentially to skim across different sources of data so that you can use the engineering information here, but then you can use the customer facing part name, for example, or part number that in a different database. And so you're able to collect all that together and make sure that the right information is getting to the right people in the right way. So it's a nice, it's a nice way to let 3D geometry play a part, but also be able to leverage all the relevant information across different sources at the same time and bring it together.
Great call, Jim. Thanks. Perfect.
So I have a question about this. So is this a sort of public Vertex marketplace where I can find different parts from different companies? Or is this like a private thing, private marketplace that I would send to make
companies would use Vertex on the back end for the visualization, and then they would then host their own environment. So
okay.
Customers are building their own catalog. They have their own catalog user interface experience, and they're moving the 2D or 3D bad experience out, and they're embedding Vertex in, and then wiring it up so that each customer gets their own unique experience. Like, welcome back. Here's what you own. Not, they immediately know what they own. They can select. They know that part is the right part, but they do it all through 3D geometry supplied by Vertex visualization.
Very cool. Very cool.
Perfect. With that, if there aren't any more questions on kind of this experience, another one I want to show is something that seems quite simple, but in practice can be quite difficult. Work instructions. So I will pivot over to that here quickly. So this is actually an experience that you can get to and leverage within from our website directly. This is our developer website. We have 3D work instructions, so a digital twin with actually views and work instructions for someone on an assembly or repair shop. So we'll hop into what that looks like. So we're starting with our supercar here, and we're going to look at how do we install, you can see upper right here, a spindle, right? So the part that mounts the hub that carries the wheel. Seems very straightforward, but if you're thinking about the way you want to ramp new technicians or reduce variation in terms of how they're installed, traditionally you might have work instructions that were printed on paper and posted at the station, right? And we all know the minute we print something, it's out of date, it's stale, right? There's no connection back. Changes that somebody, an innovative technician, finds and wants to incorporate don't propagate back upstream. That's very difficult in terms of kind of sharing that information. So what we're going to start here is simply, how do we do this? And we'll see a quick summary. We have 15 parts that should take approximately 5 minutes, and there are 4 steps in this process. So I'll begin the assembly, and first you'll notice it flew right into and highlighted by ghosting out the other parts what we need for this step here. So if I click on the actual parts list, the kid in me here, this reminds me of my Lego sets, right? Where it would say you need these parts and this many of each part for this step. It's effectively what we're doing here, but on at a vehicle level. So we know we're going to interface with the hub and spindle. And what's going to happen is we need to, for this very first step, we're going to add these 3 bolts with Loctite. It's linked back to the manufacturing system, information system, and service instructions. So we're merging data sets along with the geometry itself. So we're putting that context around the geometry. So I can click and highlight and see, okay, there's the hub that I'm mounting to, and I can see the bolts and what I need to do with them. You still have the ability to fly around and manipulate this, so I can see this in space. It can be good to see kind of what other parts am I going to have to work around, right? It really gives much more context than just the part itself. However, if you want to isolate, we'll move over to step 2 here. Step 2 is a little more involved. I've got ball joints that we're interfacing with, and I might want to actually just say, hey, show me only what's here. I don't want to see this in the context of the vehicle. But I have the ability to turn that on and off, again, because this is part of the larger CAD ecosystem. We have access to all of that. So by turning that back on, I can see what I may have to work around. But I can go back to my work instructions, and I can see here, right, I'm going to clean the spindle, the ID of that hole, and mount it to these ball joints. Something that's very important here is we can actually, because of this tie to the system, I can report an issue. For instance, I'll say, hey, the work instruction said use brake cleaner and degreaser. I can say this is related to the spindle ID and, needs wire brush as well, right? So I can very quickly submit an issue related to process. I could submit a quality defect. I can start to say, hey, the spindles we're seeing come through here, create an alert at that workstation. It can halt the line if it needs to. It can go back to engineering. It can go over to manufacturing. So again, by doing this, in the platform itself, this experience we've created, it really streamlines that communication and gets the right people the right information that they need. What would happen today is I'm going to take that paper instruction, I'm going to pick up the phone or walk over to engineering and show it to them and leave my workstation, or I might just move on, right? You can see a whole host of benefits that would happen here by having these work instructions directly in here. And by leveraging the snapshots, we see it in the context that makes the most sense, but we also haven't lost the overall orientation of the geometry itself.
Yeah, I like what you said, Chris. I mean, the key here is the technician is generally not measured on, they're measured on turnaround time, tack time. They're not, and then, oh, by the way, do a quality issue if you can. So if you can make them, put them in a position that they can quickly capture the problem, and he doesn't have to say any more than, because they already know with the geometry there that it's this configuration of this product at this moment in time. They will know literally exactly what that is. And then that can go to their quality system, and then on the receiving end, they don't have to find out any more information because the 3D shows up and they can go, if he says a bolt is leaking, he doesn't have to, if you click the fourth one there, Chris, he can select that bolt. So it doesn't have to see, well, there's 5 bolts. Which one is the problem here? He can select the one and they will literally know that bolt is the one that's leaking, that sort of thing. So the whole point is give them a great experience to capture it quickly. And then on the quality receiving side, they're able to see immediately what the technician was talking about with, trying to save time. So.
Yep. And as these work instructions get updated, right, they're going to flow directly through. So as we make improvements in process or identify and resolve quality issues, those will propagate through directly and be available in real time as they're published. Okay. So very quick overview. Again, it seems like a very simple application, but a very, very powerful and important use case in terms of assembly or serviceability of parts and components. With that, I will stop sharing. We can have a little bit of discussion then.
Well, we'll do one more. We'll do
kick it back over to you, Jim. Sorry.
We'll do one more IoT demo.
Sure.
So this is a kind of a nice way to highlight the convergence of Internet of Things data. That's what IoT stands for. But what that means is this. So like, let's say you have connections, you have sensors and other information that's, let's see if I get there. All right. So you could have a plant like this, and then there could be sensors all over the plant that would ultimately be delivered through a dashboard, so graphs and 2D dashboards and that sort of thing. And then, unless you have the plant memorized to say, hey, pump 7 is running high, or it's not performing as you want it to. And you would need to know where that pump 7 was. But if you're able to take the 3D geometry of the plant, and then you map on top of it the streams of information coming in. So like, for example, here, if I do a mouse over, you'll see that there's a graph that shows that this is the performance of this engine at this moment over here. And then if I wanted to dig in on that, I can click that, it'll zoom in, and it allows you to see the 3D geometry here. And you can also tell that we did a material override of this to say that it's healthy because it's green at the moment. So, versus having to be a student of the plant and understand the dashboards and all the reams of data, if I asked a 5-year-old, tell me where there's 3 problems at this plant, they're immediately going to be able to go, there's one here, there's one here, there's one here, without any knowledge at all about anything. And so like, if say you do have a low pressure detected, you can click on that, you zoom in, you immediately see these are the parts that are not performing appropriately. And it allows the plant manager to walk around again with like a mobile device, their tablet, whatever. They're able to go in, see this information, see what the area is being impacted, and be able to go from there. And then even like this conveyor, for example, a conveyor could be very long, but you'd be able to to say, well, this part of the conveyor is what's having a problem. So it allows you to take the 3D geometry, in this case, do a cross section of it, and then highlight a subset of that area to say this is where the issue is. And so it's a nice way to marry, sensor data coming in and align it to what would traditionally have been a very, very challenging effort to merge the 3D geometry with the sensor information, that sort of thing. And if you notice also that there's trucks and things moving around, so if they have GPS emitters, then you can take those and map them to the equipment here. And I'm going to turn it off for a second. We talked about before that you don't need to go simplify or reduce the model. You can go all the way in and see this could be the actual 3D geometry of the actual truck and be part of this as well. So the idea is to make, put you in a position that if you have the geometry available, by all means, put it into the right experience for the right purpose and not be blocked, as you would have been traditionally.
Yeah, go for it, Simon. Go for it.
Are things like alarm states defined on the Vertex side, or are those defined on the IoT side? How's the interaction work?
More on the IoT side. What you do is you map So like a threshold, like a sensor, if it hits this threshold, you map that experience to say, if it hits that, then make this area turn red, in this case, or turn green or whatever. And so you just align through the Vertex SDK, to the mapping of the sensor information to say, if this event happens, then make the geometry in the Vertex environment do this. And that's how you bring it together.
Thanks.
Yep.
The question I was going to ask, so is this digital twin, is this one big CAD file, or do you provide a canvas to where I have to place all of my things in place and then put it together? How does that work, sort of putting this digital twin together?
Yeah, so we have a concept. So I kept alluding earlier in a negative way, I guess, to you have to open the CAD model or the CAD software. You have to create a node and you have to start dropping geometry into like a bomb. The way we get around that is we have this concept called scenes. So you can essentially bring in whatever geometry you want into the scene. And so your question is so the plant mostly is one piece of geometry, and all of these other assets, the trucks and things, were brought in into the scene. So you had the plant first, then you brought in all of the trucks and things. And that's how you do it. You can then, if you need to put a new position or orientation to the geometry, then you can apply that in the context of the scene as well. So it's kind of a mix, but the answer is you can do, it's very flexible. You can do it how you want. Generally speaking, what we do is we'll take the final position orientation of where it is positioned in the CAD software, and that's where it's going to show up in Vertex. And then if you need to add influence to that, then you can apply a transformation matrix, in Vertex as well. Or if it's coming from some other source, like the trucks moving around, for example, would be, some position orientation based on the GPS emitter. And then we would apply that dynamically in the context of the scene for the trucks moving around, that sort of thing.
Got it. Thank you.
Yep. So I think that's it's a lot that we could spend all day on this, but we tried to keep it as high level, but getting as much detail as we can. But we know it's kind of drinking out of a fire hose. We tried our best here to give you the right granularity.
If anybody in the audience has any questions for our experts or would like to see anything more detailed, go ahead and put it in the chat and we'll get you some answers.
Yeah, and in the meantime, while hopefully some of those questions roll in, you showed 4 different use cases, 4 different services and or solutions. How do I get started if I'm interested in getting going with some of this?
Yeah, we have a couple ways. You can go to our website and request a free trial, either through if the Connect tool is how you would like to get started with us, we can give you a free trial of Connect. I think it's 30 days, something like that. If you're a developer who would want to investigate embedding us into your applications, then we have a developer portal and a trial on the SDK as well. I'm not a front end guy, but whether you're using like Node or React or those sort of things, we have different, the SDK is usable for all of those sort of modern methods of doing front end development work.
Yeah. And I'll say, the requested trial right quickly through the website, because the AWS flexibility, we can have it up and running very, very quickly, right? It's practically an immediate turnaround there. What we showed today, right, public cloud, but we do have a lot of flexibility with private VPCs and even GovCloud. So important things to call out there, because if you think about proprietary nature, we do have ways to support this because of the flexibility you've given us as partners through this relationship.
Yeah, it's kind of a modern way of thinking, but for sure. But yeah, thanks, Chris, for bringing that up again. That standing up in someone's VPC is something we can absolutely support, and we do it. It's usually the number one thing they want to do with us. For customers, the way AWS, we need to tip our cap to you guys, because you're some of the leaders in IP protection, and that helps us a lot. So whether it's doing VPC or GovCloud or even the multi-tenant environment, we think is very, very secure. and it's actually perfectly fine for some of our customers as well. Like they don't necessarily need us to stand up on a VPC environment. So yeah, we're really able to support really any way that you guys want to use Vertex and make sure that you're comfortable with how your information is being secured.
Awesome. Thanks for that. And I'll just piggyback on top of that. You have an AWS Marketplace listing as well. So if anyone out there is familiar with AWS Marketplace, definitely check out Vertex's Marketplace listing. Those are, a bit of work to put together, and definitely it's a really easy way of getting started. So I'll drop that in the chat now, the link to this Marketplace listing here. All right, looks like we've got no questions in the chat. Looks like the chat's just a little bit shy today, but that's okay. Definitely reach out. You can reach out to any of us at any time, whether it's myself, Simon, or definitely I'm sure Jim and Chris are happy to talk more about anything today.
Very much.
Yeah.
Yep.
Jerry, Simon, thank you for your time. Appreciate it. It was a great session today.
Definitely. Thank you. Thank you for coming on the show. It was great to see this live and in action. Super useful use cases there. So it was great to see them. That's what we love about the Howdy Partner Show. We start off with a little primer, but it's all demo focused, and I hope the audience got a good taste of what Vertex is all about. So thank you both so much for being on the show, and to the audience, thank you so much for tuning in. We really appreciate you being here, and definitely check us out every Wednesday. Same time, 5 p.m. Eastern.
Thanks for the opportunity. We appreciate it.
Thank you.
Awesome. Thanks, everyone. Till next time.